So thanks for coming out tonight. I appreciate it. I've been wanting to come to this meetup for a while, and finally made it. This isn't quite how I intended to come to my first Columbus Elixir meetup. But we're going to talk about implementing a custom logger backend tonight. So we'll quickly talk about who am I and why you shouldn't listen to me. What motivated me to go write a custom backend. Kind of talk about the logger interface and implementation, and we'll wrap up with my Prometheus logger demo. So who am I? This is not in sync. That's me. See if I can actually make this work. There we go. Sorry about that, folks. Anyway, so who am I? I'm nobody. Think for yourselves, as always. A little more seriously, McClellan. You can find me on Twitter at rubberduck203. I've been in software about a decade, close. Polyglot and generalist, so I have done everything from embedded development, web, desktop, big data, C++, Elixir, C#, F#, Rust. I like Rust for fun. And I am a former Smart Columbus OS developer. That's where I did most of my Elixir. So that's me. Take it all with a grain of salt, because I am not an Elixir expert by any means. So if you see something up here tonight that's not right or not idiomatic, kind of let me know afterwards, because I'm not actually that good at this. So what motivated me to go create a logger backend? So OTP is really good at restarting processes when they die. It's too good at it. So how many people have made a code change, made maybe a configuration change, and then they push their code out and realize that one of their child processes just keeps dying and restarting and dying and restarting, right? Yeah. So what I really wanted to get was a near real-time visibility into the number of errors and warnings that were occurring in the system. Right, so if we can just log warnings and errors as normal and somehow see that in real time, that would kind of help us spot those cases where OTP is doing its job and we mess something up. So to do that, I don't know if the OS is still using Prometheus for the monitoring system, but at the time we were. And this, I don't know if this ever got used in the OS. I kind of built it as a proof of concept. But we decided, we've already got this monitoring system, Prometheus. I'm going to try using it and see if I can do something here to get a count. And I was able to do that. So this is a screenshot available. It's actually on the README of Prometheus logger. And what you see here in red is that's a count of errors, recent errors, over the last 30 seconds, and the count of warnings as well. Right? So I was able to accomplish this. So that brings us to logger, right? So we've got the motivation. I want to be able to see these warnings and errors happening, and the easiest way to do that is to just hook into logger. Is this not big enough for you guys? Some people squinting. Yeah. Oh, it doesn't actually get bigger. It doesn't make it bigger. Sorry about that. Lesson learned. I will use a bigger font next time. Yeah, I don't bite. It's okay. So logger is really interesting because it is event-driven, right? So whenever you call log.warn or log.error, what happens is logger just sends an event to any registered listeners, right? And normally that's something like console, right? Console logger. I know there's a file implementation that's reasonably popular. So this is the interface to GenEvent, right? And so you got init, handle event, handle call, handle info, terminate, and code change, right? So those are all of the functions that you have to implement in order to satisfy the GenEvent behavior. Now, for logger, a basic implementation, the one I'm going to show you tonight, really only has to handle init, handle event, and handle call. Right? So I didn't handle info or terminate or code change. If I really flush this implementation out, I probably would in some way. But for the proof of concept, I didn't need to. So handle event, this is the format that we have here. All right, so we have, what happens is when logger's called, so logger.warn, right? What we're going to get is we're going to get a warn atom in that level, a group leader that specifies what Elixir node did this originate from. The logger atom, so the logger up there is actually just an atom. The actual message, the timestamp, and then some metadata. And please don't ask me what's in metadata, I don't know. All right. So a couple of things here. This is or flush. The other thing you can get is the flush atom. So if you get the flush atom, you need to go ahead and flush all of your pending data and make sure that it gets stored. So one of the interesting things here is also group leader is recommended. It is recommended that group leader ignores any message that doesn't come from the current node. Right. So let the node that originated the message log it is the idea there. So again, we're not going to use all of these fields in the implementation I showed you tonight, but they are all there, and you probably would use them in a, I don't know, if you write a MySQL logger or something, you'd probably use most of these. For Prometheus logger, we didn't. All right, and so this is our init function. All it does is it declares a Prometheus counter. Right, you got to tell Prometheus that, hey, there's going to be this counter in the future, right? You register it. Then we get the application environment, so any settings that the developer set to config access. And if there are none, we say the default is level 1, right? So it seems like a reasonable default that we only want 1 and above. And then we return that state, right? Super simple. Right, then we get to handle event, right, and this is that event struct, right, so whenever you call log, this event is raised. So all we do here is we say, okay, logger compare level to what is the minimum level in our configuration that we want to log. And compare level gives us either a less than, greater than, or equal atom. So I just say, okay, so if it's less than our minimum setting, just do nothing with it. Otherwise, increment the Prometheus counter. Okay? And then because Prometheus is a scraping model, we don't need to flush anything. We're not really writing anything. So when flush happens, we just say, okay, and give you the state back. The next thing we need to do is handle call, and this is for setting configuration. Right, so if we get a configure message, we just take the options that we've been given just now and merge them in with our existing configuration. Right, so if there's a key already in there, we're going to overwrite it. If the key doesn't exist, we'll put it in there, but otherwise we're going to leave all the other state alone. And if you're curious about why that's useful, I'm not going to talk about this tonight, but it's out there, and I wrote a blog about this. You can change Logger's configuration at runtime. Right, so I can set my app up so that by default, in production, I only log warns. But then something bad is happening, right? So warn's not really giving me enough information. I want my debug messages. I can actually connect to my live nodes, set the logger level down to debug or even info, and start dumping out all that very verbose information and see what's happening in my production environment. So that is why you need to handle configure options. That's it. That's the whole logger implementation. Right? That is less than 50 lines of code. Right? It's not a full one. If I really went and fully baked this, it might be twice that size. I think even the console logger is only about 150 lines of code. Right? So at least it's almost it. We haven't used it yet, right? So the last kind of step here for us to use this logger is to go actually configure it. So what we've done here is we've just added the logger backend Prometheus add-on, right? So normally we just have that console there in that configuration. And we just say, okay, give me console and give me the Prometheus logger. And logger is going to take care of finding that atom, loading the module, registering it for the events, and all that for you. And then this here just shows how we merge that state in, that configuration, right? So if we wanted to not have a default level of warn, we just say, give me level info, that's the minimum level in our log. Demo. Let me see if I can pull this off. Chris, can you make it that? Yeah, this doesn't matter. I'm just pulling up some Docker files. Okay, so this is what Prometheus looks like. Okay, so I just brought up my Prometheus instance. Right, and at this point, we don't have any metrics. Right, it's not scraped any metrics from anywhere because we've not started anything else. So let's go back. I will embiggen this very big. And we'll CD into our cowboy example. I think I'm embiggening it too much. All right, so our dependencies are up to date. All right. So now we've got our our IEX shell. We're just going to say require logger, and then logger warn. So what's interesting here is we've registered the Prometheus logger, right? We're still getting those console messages, right? This is an additive process. We're not replacing one logger with another, right? Like a lot of, I know in C#, right? Like you add a back end to a logger, and you're totally replacing your logger for that run, for that environment, at least in a lot of systems. Here we're adding loggers. We could add 4 or 5, right? I don't know why, but we could. And then we can also say logger error, and this time we're going to blow up. And let's do that a few times. All right, so now if we come back here to Prometheus, we'll see. Maybe. I'll have to refresh. There we go. So if we just search for logger, we can execute this. Probably a little hard to see over here. All right, so we can see we've got 6 at level of error, 1 at level of warn. And we can go over to the graph. Possibly, I might have to add a few more here. Let's go back. Just throw a few more events out here in the logs. Give this a second. Re-execute this. So, and you can start to see this come in. It takes a moment, right? So we go, hey, I've got 1 warning. Now I've got 3. I've got 6 errors. That number's going to jump up here the next time it scrapes in about 15 seconds, right? So then, this is interesting, but it doesn't tell us a whole lot for a live production system, right? This is just going to keep counting forever. And this is just kind of an idiosyncrasy of time series databases. What we want to do is we want to say rate EX logger over 30 seconds. I think that looks right. Right, and now we can actually see that rise and fall. Right, so we had a brief period of time where we got a lot of warnings, a lot of errors, and now we're back to normal. Right. So that's the demo. And just a few closing thoughts I have here. Implementing your own logger is ridiculously easy, right? So if you've got some existing, I don't know where you're logging your Ruby messages to or anything like that, or maybe you've got Java and it's logging someplace, and you don't have first-class Elixir support for that, it's really easy to go write it. You got to put a little more thought into it because you're probably going to want actual messages, not just counts like I did. Right? But it's not hard to just build a queue and as you have time to process them, write them out to disk someplace. This I actually think is more interesting. Right? Logger is designed with an event-driven system in mind. Right? I mean, Gen event is kind of the dead giveaway to it, but you can design applications like this in almost any language, but it's super cool because I don't have to really, it's not like implementing a behavior and then I can only really have one of those behaviors swapped in at runtime, right? If you're using events, you just broadcast the event to anybody who's listening, right? So I can have additive behaviors, and I can have lots of things listening to the same event. Email, user registration is usually a great example, right? I register a user, and I want to do a couple things, right? One is I want to write that user to the database. The other is I want to fire them an email. And maybe I also want to send a notification over to the marketing system so that they can follow up, right? Whole bunch of things. And if you start to write that procedurally, that method, that register user method, just becomes a mess. Right? But if that register user method is just, hey, we registered a user, anybody who's listening care to do whatever you need to do about that. Right? You separated your responsibilities out across very focused functions and methods. So I guess my last thought here is, for you, how might you leverage gen event or event-driven systems in your own designs? So not too bad. I'm only like a minute over time. So I do have some resources here around Logger. So the Logger documentation I used to write this, my actual Prometheus Logger, the console implementation, gen event, and the Erlang gen event. And that is all available with these slides. They're up on my website right now. So that's it. Do I have time to answer questions? Are there questions?
I have a general question about the event systems. So you made the example a little bit.
1 second, I got a mic. Try to keep the shouting to a minimum.
Hello. I have a question about the event-driven system. You made the example of user registration and how it would differ procedurally versus from the event system. I'm not familiar with the event system in Elixir, but is there a way to control, like say for example, you had two different actions that were dependent on each other that you wanted to be event-driven, that you can control which one occurred first, or is it you register the event and you have no control over how things are processed or order they're in?
If you care about that kind of ordering, I would recommend that you couple those things together. Right? Maybe you raise an event and then whatever's listening orders those things itself, but I wouldn't count on an event system to do it. But I'm also, admittedly, not an Elixir expert. I do not know if gen event guarantees any kind of ordering. You'd have to look into it.
Sorry. While I'm holding the mic, I had a quick question. What happens when your Logger, if your Logger implementation crashes?
Logger restarts it.
Nice. Does it print out a message that says that it crashed?
I wrote this a long time ago. I don't know.
I'm always curious because yes, that's when these things tip over. They shoot out a lot of sparks.
Logger adds it to its supervision tree and starts it, and if it dies, it restarts it.
Makes sense.
So also a question about the event system. Might have been actually the same question, just, okay, so imagine a diamond of events that all sort of require and depend on each other. Say the first one's user registration. And for your convenience, user registration, let's say, just has an event for, I guess, idempotency or whatever. And it has two kind of events that require that event, and they both execute, but there's yet a third event that doesn't, the main issue is that it doesn't just require one of the two events, it requires like save to the database, it's going to read from the database, and it also requires, I don't know, that some email's been sent out, like it's going to take in two events. Is there some kind of queuing, like, are you more familiar with that?
So I'm way more familiar with that in a language like C#,
Okay,
which also has a very great first-class event system. Yeah, I would probably use a queue. So just start queuing things up, and as the second event comes in, I start processing out. Right?
Cool.
also, I try not to get into real complicated trees of events, right? They're nice for when you want to notify of something happened, but if you're really wanting to do control flow, you may want to just control the flow in a more traditional way. All right. That's it. Thanks, everybody. I really appreciate your time.